This is AWR Microwave Office tutorial series. In the previous tutorial, we have learned how to model a microstrip transmission line in AWR design environment. In this tutorial, we'll try to understand the effect of change in line width and change in the substrate height on the transmission line impedance. So let's get started. In the first step of this video, we are going to run AWR design environment. And we are going to open the previously created project, which you can download using the link given in the description. Now to open that, we'll go to File, go to Open Project. Just locate where you have saved the file. In my case, it is saved here, and just select microstrip _ impedance.emp file and click over Open. Here we go. So this is the schematic that we have simulated in the previous tutorial. Now here, first we are going to see the effect of change in line width on the impedance of the transmission line. To do that, we are going to run the sweep analysis on the line width, and for that we have to place an equation here. So let's place an equation using this toolbar, and here we are going to, let's name it width, and its default value is, let's make it 1 here, and we are going to change it to W. Alright, so currently the width is WMM. Now we are going to place the sweep variable here. To do that, we'll go to the library by pressing Ctrl L in our keyboard and search for SWP. This is the one, sweep variable control, and click on OK button. We are going to place it somewhere here and just click over zoom fit button. Alright, so the variable name in our case will be W because we are going to change the W here. So we'll just put it in this double quote and select it here. Now in this value option, here we have to put the parameters. So the first will be the starting point of the width or the start of the sweep, and then we'll have the stop of the sweep and then steps. So in our case, we are going for 0.1 mm change. And now after setting up everything, make sure the value should be selected at stepped. So let's type stepped function here. Here we go. And this should be written within the small bracket. Alright. So now everything is set here. Now we'll go back to graph, add new measurements. Here make sure you have selected the port parameters, Z. Select the correct data source name. And for sweep frequencies, as you know, we have already set the sweep frequency to 1000 megahertz, and this is the single point, so there is no sweep in frequency. We are sweeping the width of the transmission line. So here we have the sweep variable, and which has 91 points. Now for that we are going to select use for x-axis. So on x-axis there will be no frequency but the width of the transmission line, and click over add and close. Now we are going to run the analysis. To do that, we'll click over this analyze button. Here we go. So here we can clearly see impedance of the transmission line. So currently the impedance of the transmission line is selected as real. We are going to change it to magnitude, so we can see in terms of ohm. All right, here we go. So now we can clearly see as we are changing the width of the transmission line. So it is 50 ohm at across 2.9 mm. which we have calculated in previous video. All right, and when we are changing the width of the transmission line or making it thicker, the impedance is going low, which makes sense because the capacitive coupling between the signal and the return path will increase. All right, and as we know, Z is inversely proportional to the capacitance. All right, so as we are increasing the capacitive coupling, the impedance will go low. So this is the sort of effect of change in width on the impedance profile of microstrip line. Next, we are going to plot for what happens if we change the substrate height of the stack up. So currently we are just going to make our width fixed. So in our case it was 2.9 mm, and this time it will be the substrate height. Let's make it HS for substrate height. Variable will be same, HS, and the substrate height currently it is 1.6 mm. We are going to sweep it from 0.5 to 3 mm. So let's change these parameters here. So let's make it 0.5. This will be 3 mm. And step size, make it more smaller. So let's make it 0.01. All right. Simulation will take a bit longer because of this so many steps involved here. And let's make these two HS. Here we go. Next, we are going to modify the graph. To do that, we'll just double click over this measurements. Here we have to change couple of things. So make sure you have selected the correct schematic. We are going to plot for impedance, and sweep variable will be on the x-axis. Frequency will be thousands. Make sure you have selected magnitude here so we can see impedance on y-axis. So it's pretty much same. Let's click over OK button and run the analysis. And here we go. So as we are changing the substrate height, the impedance is going higher. And the reason is pretty much same. The capacitive coupling will go low. And as I've already told you, the capacitive coupling is inversely proportional to the characteristic impedance. So we are lowering the capacitive coupling and the impedance is going higher and higher as we increase the substrate height. So yeah, similarly, you can play with other parameters here. For example, you can change the value of dielectric constant, all right? Or you can just change the value of tangent loss, all right? And see what is the effect of that on a microstrip transmission line. So this is how we can understand using these simulations the behavior of transmission line when we change certain property of that, all right? Next, we are going to save the project. To do that, we'll go to File and click over Save Project. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.